Fundamental object-oriented design principles. Use as a guidelines to avoid a bad design of your software. Now we will briefly explain each one. First of all, Hind, can you explain to me the encapsulation principle, please?
Yes, the encapsulation principle is a mechanism used to hide data and the internal structure and implementations detail of classes. All interactions with the classes through public methods. Now we have a violation Java code of principles encapsulations. Now we have a public data field and a public method. The correct one, now we must have public methods and private data field to avoid the access of data class. Now we have a correct Java code about the principles. Now convert the data field private and we access the private data field through the public through the setters and getters methods.
I see. So what's the benefit of this principle?
The benefit of this principle, encapsulation principles, changing a class internal, not affected any code outside the class, and changing implementation method, not reflect the user to using them, and reducing complexity when we hide the implementation detail of classes.
Thank you. Now I got everything. Thank you, Hind.
Hind, we are here about single responsibility principles. Can you explain it for us?
Yeah, single responsibility principles say each classes handle one responsibility. If the classes handle more than one responsibilities, we need to separate each responsibility in separate class.
And why it's important to separate responsibilities in separate classes?
Because each responsibility is a point of change, and if we need need to change the classes, so we have more than one point or reason to change the classes.
Can you give me an example?
Now I want to give a violation Java code of this principles. This example talk about class employee have more than one responsibilities in classes. Class one responsibilities, the first responsibility is employee no and employee number, and we can insert the employee through these classes and generate a report through these classes. All these responsibilities through one classes. So we have more than one point of change of these classes.
This is a violation example.
Yeah.
Can you give me a correct example for this?
Violation Java, a correct Java code. The correct Java code, we need to separate more than one responsibilities in the violation Java code and separate responsibilities or functionalities in correct Java code. So we make the class employee, make the employee and employee name, and separate class to generate the report, and separate class for employee database. So we need to change one class, or when we need to generate the report, change the first the one classes اللي هو generate the report, and we need to insert logic database or logic database for the employee. We need to change one classes is the employee database. Just
the third principle is interface segregation principle. This interface all about a well-designed class should have one and only one reason to change.
What do you mean by this?
The interface segregation principle states that the client shouldn't be forced to depend their own method that they don't use. A client shouldn't force depend upon the interface that they don't. For the violation of ISP, we have this UML diagram. We have by class and better class. By class have two functions. The most important is a request by amount, and better class have a request per amount. These two classes are connected to the interface through dependency relationship. The interface includes two methods: request by amount and request per amount. For by class, it's not important to know the implementation of request per amount, and for the pro class, it's not important to know the request by amount. As implementation for the previous diagram is we have the interface AP. We have a class library is the basic class, and class by is the subclass that extended from the basic class, have a request by amount, and we have the pro class. It's another derived class or subclass, and those two classes are implement the interface is AP.
And what is the solution for this violation?
The solution is we make two interface, each one for different class. Interface called by AP is for class by. If this interface implement the method just request by amount, and the interface pro AP implement the method just request pro amount. This when we make this interface, we solve the problem. The correct implementation, we have an interface by AP, interface pro AP, and class by that implement the interface AP by AP, and the class pro that implement the interface pro AP.
Areen, Dr. Mahmoud asked me to present the loosely coupling principle in the lecture. Can you help me understand it, please?
Coupling is measure of the interdependency between classes. If every object has a reference to every other object, then there is a tightly coupling, and this is undesirable. Loosely coupling is desirable. Loosely coupling is reduce the degree of interdependency between classes.
What do you mean by this?
I will explain it using this example. The violation of loosely coupling in this example. Class tests have a direct pointer to the class TV. This is called a strong coupling, and this strong coupling is not favored for design. The Java code for the previous diagram is have a class public class test and class TV. This is a strong coupling because we have two classes, and the class is contain a pointer directly to the other class. The solution of strong coupling is a loosely coupling. That means the class test have an pointer to interface just, not to the class. For the Java code for the previous UML, we have a public class test. This class is contain a pointer only to the interface called TV interface. This is the solution, and we done the loosely coupling. It's the perfect solution for of design.
Now I have the enough knowledge to present it in the lecture. Thank you, Areen.
The open-close principle. The open-close principle should be open for extension but closed for modification. This means allow for adding a new function without change a source code. You can do this using abstraction, inheritance, interface, and polymorphism. This is a violation class diagram. This is a class editor, and this class rectangle, circle, and shape. The graphic editor dependency or rectangle and circle and shape. If you add a new shape or change of any one, you can change class graphic editor. Okay. This is the Java code for a previous violation UML diagram. This is a class graphical editor and the class shape. Class rectangle and the class circle make extend from shape. A class shape include attribute type. You can and this class editor include function. You can use attribute type to help me to draw each shape.
Bayan, what is the correct solution for this problem?
This is correct. This is correct a class diagram. Now you add if each class a draw shape. Now if you add a new shape, you can print this in a graphic editor without change origin code. Okay. Correct Java code. Now add method void draw. You can use it in rectangle and circle. Then if you add any shape, you can print it using this function. يلا اللي بعدها. الانترفيس ما سألتينيش انت يا على فكرة.
لا سألتك شو الكوريكت.
بالله؟
حبيبتي.
طب هلا استني وين هاي؟ طب انا شرحت هنا.
عشان نختار
Each interface must be public without perimeter. Okay. أسجلها.
لا.
أنا مش فاهمها على فاهمها شو يعني طلعت أنا بتاع هندي كتبع بيان على الأسئلة بالكلاس ريبو ستوب
Hi Rina, can you explain the dry principle please?
Yes, Irene. The dry principles is to remove the duplicate in your code. So I will give you an example to understand it.
Okay.
If you have a print statement, 100 print statement, and you want to change it, something in this statement, you will make change 100 times, and it will be a cost on your time. So here in our example, we have 3 statements to print, and if we want to change this one statement and 2 and 3 statement for print, we will have so much complexity and reduce our time. So we will make a correct Java code. We will see here we make a method print and it has an index. We will pass the index for this function, and we make change that we want.
Rina, someone asked me about the least knowledge principle. Can you explain it please?
The least knowledge principle is used to use a less number of classes. If you have dependency between these classes, it will become more complex. So to avoid that, you must remove all dependency between these classes. So here in our violation class diagram, we have 3 classes: school, teacher, and student. The class school is declare an object from class student and object from class teacher. So here it's difficult to understand by the users, and we have a dependency between these classes. So to avoid that, we use an association relationship between them either than dependency. As we see here in our violation Java code, class school and class teacher, class student. Class school declare an object of class teacher declare an object of class student. So it's difficult to understand, and we make very coupling between these classes. But here it's very easy and very understandable for each user that is open this code to understand. and each class is declared an object of by itself. Sally, what is the Liskov substitution principle?
Liskov substitution principle that focus on definition of a subtyping. When we have two classes, one is S and the other is T, and S is the child for T and T is a parent, and then object of S can be replaced with object of T. That is the meaning of substitution. This principle is helpful in reasoning about the class hierarchies. Now, as a violation of this principle, we have first the class rectangle with a method width and height and setter of this method, setter and getter, and we have a function getArea that returns the area as width multiplied with height. Now another class square extends rectangle. It's the child of the rectangle and has a setter and getter of the width and height also. In the class test, we're going to make a reference of class rectangle and an object of our class square. When we call the reference and we set the width and height, here we give 5 and 10. Then we call the getArea methods. When we call it, the output will be 100 instead of 15. Why? Because the method the test called the method in the rectangle class, which is different than the square class. And here we have the UML class diagram for the violation, and the rectangle square extends from the rectangle. Here we have the area method. Here we don't have the area method. As a solution of this principle, we add just the getArea method in the child, which is square, also with the same attributes, width multiplied with height. And in the class diagram in the UML, we just here added the getArea method.
Dependency inversion principle, Sally, do you know anything about it?
Actually, yes, I do a little bit. That high-level modules should not depend on low-level modules, and low-level modules should not depend on high-level, so they must both depend on abstraction. As a violation of the dependency inversion principle, we have a class worker with a function for work, and a super worker extends from worker with a function work, and the class manager that create an object of the worker called worker and set it to W. The constructor called the work method here. Here the class manager depends on the worker, so any change of the worker will affect the manager. This is the UML diagram of the violation. This is the manager with set work and the constructor, and the class worker extends the super worker. As a compliance of the dependency inversion principle, we add an abstraction. This abstraction may be presented as an interface. Here we add an interface called iWorker with the function work. Now the class worker and super worker implement this interface iWorker and implement the code work differently. The manager called the iWorker, and then the constructor called the work method. The UML class diagram is the same, but we here add an interface iWorker with the function work, and they are both these classes implement the interface.
The final principle is interface principle. Interface principle is that told about interface take a method and interface that's implemented by classes and provide implementation, and each class must provide implementation for every method in the interface, and the access modifier of method in the interface must be public. The violation of the interface principle like that. We have a student class, and this class is implement a university interface. This interface have a method called print student ID. Print student ID, the access modifier for its method private. This is the violation of that principle. When we look about the violation in Java code for the previous example, that the interface university include the method called private student name. It's a private. You can't add any access modifier private or protected in the interface. The access modifier in the interface is public. The correct solution for this problem is identify the methods in the interface as public. Never identify the method as private or protected. The correct Java code add a public modifier for the method in the interface called print student name.
Now we hope you enjoyed our presentation. Thank you for listening.